over these here. Real quick, the very first thing I would do in this kind of problem is look through what I got to do and actually just take a second and figure these out. What did you guys get for the vector RS? All right, what did you get for the vector ST?
-1, -3, 5. Yeah, 5.
And that's all you need for 1A through D, right? Just those two things. E, you need RT and TR. So part A, I kind of made it purposefully slightly evil. It's got a lot of steps inherent in it. So you need a vector in the direction of RS. So that, again, whenever I give you a vector in any form, it inherently has a direction in it. So there it is. That's the direction I want to go in. But I don't want to be as long as it. I want to be as long as this guy. So I keep trying to kind of give you these mental images to make a building block that I can build off of. I got to first calculate a unit vector, right? So I want it in the direction of this. So to make the right unit vector, I've got to take this divided by
its magnitude.
Its magnitude. And if you, I mean, you can do this in steps. If you really want to, you can multiply it by the magnitude of what? How long do you want this thing to be?
Yeah.
The magnitude of this guy. Let's take it in steps. So RS is -4, 6, -4. What's the magnitude of RS?
Square root of 68.
Square root of 68. The square root of 68 is what? 2 radical
34. Oh no.
17.
Yeah.
All right. And the reason that's nice is because all these are divisible by 2. If you didn't do that, who cares? Math still comes out, right? But look for that kind of thing. And to answer this, I mean, there's more I could do with that, obviously, but really, technically, all I have to do from here mathematically is take that unit vector and multiply it by the length that I want. What's the length I want? What's the length of ST?
Square root of 35.
Yeah, square root of 35. So my answer is just going to be, let me put it the way it sounds like most of you guys have it. There. Right, and then you can simplify that. I would simplify the root 68. I would bring the roots inside, and then you're done. You could rationalize the denominator if you feel like it. Who cares? I mean, that's the answer, right?
Would that'll work as the final answer, or would you want us to simplify it on steps?
I'd want you to simplify it a little bit. At least bring the stuff in, you know. So it'd be -2 root 35 over root 17, right?
Mm-hmm.
Divided by the 2, that would come out.
Yeah.
3 root 35 over root 17.
Okay.
And -2, again, root 35 over root 17. Yeah.
Cool. So that's what you'd want.
Yes, cool. And you should expect more often to get ugly answers when you're having to take a vector from where it normally is and alter its length somehow. You're going to get more than likely some ugly radical stuff. So how's that one by itself? I mean, you're starting hopefully to get the idea those unit vectors are useful for building things that I want. 1B, dot product. So of course the nice thing here is we've written what these are. So I just want the dot product of -4, 6, -4 with -1, -3, 5. So what's that? -34. I love it. And I like to do this for you also. Some of you guys probably hopefully noticed I'm building what you need for later. Okay? You've already done some of the work you need for later. Part C, the angle between RS and ST. So that's where you got to remember that the dot product is equal to that's one way to write the dot product. This we've already calculated, and that's by doing that U1V1 plus U2V2, that formulation of the dot product, right? If I don't have the angle, thank God, it's a very easy way to get it. And that's why it's nice to get to solve for the angle. I know what this is. I know what those lengths are. We had to calculate those. What was the length of RS? Root 68, and the length of ST was root 35. So just slap that into an inverse cosine. And I don't know, what do you guys get for that angle?
134.18.
Is it 134.18?
Yep.
Sound about right? I didn't do it, so I throw with what you said.
The way I have to go through the screen.
Just gotta throw that in the calculator,
So-
can't make
so
it much
that's
easier.
the engine. See how they're-
Let's see, how are we doing so far? And this is the basic building blocks of what we're gonna use to do stuff.
They prefer to have
Um,
invoice, it's like $300.
Part D.
Not do zero.
So part D is now gonna basically use everything we just done. Find the projection, which way did they go? RS on ST. By the way, if I really should have given these quicker names, like I could have called one of them U and one of them B, make it easier to write the formulas out, but too bad for me. So how do you do the projection? And this is RS on ST. So which direction do you want it to go?
ST.
Beautiful, because I want it to be on ST. So ST is out there.
RS times ST. RS dot ST over ST.
Yeah, over.
Magnitude
ST
squared.
minus square.
Yeah, ST. Magnitude squared, yeah, cool. Now, we did calculate the angle, so if you really wanted to, you could use the other formulation of projection with the angle in it. I wouldn't either, because we've got everything else too, right? So RS dot ST was the negative 34, right? Yeah. The length of ST was root 35, so of course that's 35.
That's out of the screen.
And then ST is this guy.
Sure.
And then you can multiply that in. If you don't, I'm not going to take off because the book does it that way. Cool.
Okay. Just see it.
Okay, and I think that's the last one. So before I let you go, I want to talk about one thing that's going to help us do cross products. And then I want to do a little bit of a preview of 11.5. So we got what they want here?
Someone there, right?
Is it really? I had no idea. Oh my god. Discussion.
Yeah.
Discussion. Discussion.
Dissolution, yes. Sine dissolution.
Is that one of the new words? Does that mean perpendicular?
It's a brand new word. I haven't even figured out what it means yet.
Perpendicular.
In order to do cross products easiest, if you know how to determine the determinants of matrices, it will make the formula that much easier to do. So I think I asked this before, not too many of you had done matrix determinants before. Hopefully we've all worked with matrices at some point. I'm trying to figure out the best way to do it. I think the best way to do this is just tell you how it works. The determinant of like a 2 by 2 matrix. So I'd have, so a 2 by 2 matrix would look like maybe 3, -1, -4, -2. So there's the matrix. The determinant of that matrix would look like this. Radically different. They took the little bits off. Right? But that tells me to find, and you can think of it, I think I told you this before, vectors are examples of simple matrices. If you start trying to do similar operations on matrices, you start getting the freaky ass math. I mean, freakiness. It's called tensor calculus, which gets exceptionally freaky. We're not going to go all that. We're just going to talk about how do I find what's equivalent to the length of this in a way. And who knows, I think a few of you guys know how to figure this out. It's sort of like cross multiplying in a way, but it would be 3 times -2 minus -4 times -1. And then you get -6 minus 4, so you get -10. And if you do linear algebra, some of you guys, if you've done it, The determinant being 0 is an interesting situation, or non-zero tells you certain things about the matrix, and all that kind of business. Where have you done matrices before? Hopefully you've done them when you're trying to solve systems of equations. Have you guys ever done like row reducing, you know, like adding two rows together and such like that? Okay. So they are related to solving equations. If I want to find the determinant of a 3 by 3, so I could have something like 2, 1, 3, 4, 0, negative 2, 1, 1, 0. This kind of sucks. It's not going to be as easy as this was. But it's sort of the same idea. I still kind of do like this in a strange way. I pick a row or a column to do this with, but notice how I can't do like 2 times a number, because there's not a number here. There's another little matrix here. So I'm going to kind of purposely do this in a stupid way, and then we'll go back and do it a smart way and see that we get the same answer. Right? So just deal with me being stupid for those of you who know how to do this. Do you guys kind of get, so here it would be 3 times that number minus negative 4 times that number. Here I'd have to do 2 times this determinant of this matrix. Oh, wait. Okay, now here's where it gets weird. So I'm going to do it around this first row. So you kind of go in order. So 2 times this determinant minus 1. Now what's 1 across from? See how 2 is across from this determinant? Here's where it gets a little freaky. 1 is not across from any determinant. It's across from these 2 things, isn't it? Mm-hmm. You guys see that? Mm-hmm. So 1 times 4, negative 2, 1, 0. So nice, thankfully, if you understand 2 by 2 determinants, they're easy. Bam, bam, subtract, you're done. 3 by 3 matrices determinants are built off of those. Thank God. So minus 1 times this, and then plus 3 times, what's it across from?
4, 0, 0.
4, 0, 1, 1, right?
Wait, why is it plus?
So here's the thing about knowing how to do. This was easy because it was so small. There wasn't that much change. To know what symbols to put, you have this little matrix to go along with it. It's been a while since I taught linear. I forget what that one's called. Oh, it's almost